Alright, this is given a vector PQ starting at -4, 5 and ending at 7, -2, so it has a direction going in that way. I want to find the standard form of it, move this starting point to the origin so I can write it as AI plus BJ. So the first thing is, I want to change the x coordinate so that it becomes x is equal to 0. So we're going to move it over 4 units. So we're going to add 4 to the x coordinate. Well, that's the same thing we're going to do down here. We're going to add 4 to the x coordinate of the Q piece. And the second part is we're going to have to bring it down 5 units. So we're going to be subtracting 5 from the y coordinate of the point P. We'll do the same thing to point Q. So that becomes 7 plus 4 comma -2 minus 5. So the ending point is now going to be 11 comma -7. So the vector is going to be written as, in terms of I and j, 11i minus 7j. Formula-wise, it pretty much works out as x2 minus x1, y2 minus y1. Kind of like slope, except you want to keep it in coordinate form. So if I have a little bit more complex one, where I'm using some scalar multiples of vectors, so this would be 2 times vector v minus 3 times vector w, where v and w are -2i plus 3j and 5i plus j respectively. The first thing I want to do is I want to draw the picture of v and w. Over here is v, and this one is w. It's 5 over and 1 up, which would be 5 i's and 1 j, and 2 to the left and 3 up, which is -2i plus 3j. The next thing I want to talk about is the scalar product of them. If I say 2 times v, all that happens is this direction doesn't change, but the length of the vector, the magnitude of the vector, gets 2 times as long. And this -3 on the w is going to do 2 things. It's going to make it longer, but it's also going to change its directions. So we're going to get 3 of these w's going in the total opposite direction. So our picture would look something like this. So here's the original v. This one would be 2v. And here's the original w going in this direction. This would be -3w. And I just want to basically add them together. We can think of this as 2v plus -3w. Oops. So what we're going to do pictorially first and then mathematically later, which is actually much easier, we're going to draw our parallelogram. And again, here's our -3w and here's our 2v. And if we do our little parallelogram, this side matches up with the slope of that side, and this side matches up with the slope of that side. The resulting vector would be the vector that goes from the origin to the intersection or the other vertex. So our solution is really this vector here. This thing would be 2v minus 3w's. So the coordinate of this point way out here is -19 comma +3. So let's see if we can get to this mathematically. Much easier than drawing it by a picture. So 2 times v, and the vector v is -2i plus 3j, minus 3 times vector w, which is 5i plus j. So distributing it out, we get -4i plus 6j minus 15i minus 3j, and then combine like terms, we're going to get -19i plus 3j, which exactly matches up with what I found graphically, that vector right there.